Welcome to Simtek. My name's Jay and I'm Technical Director here, and we specialise in vehicle electrical systems for a wide range of markets, specialising in kit cars and race vehicles. We have a display here today that is a complete vehicle on one board, which gives you an idea of where you're looking at for components and what you need to think about when you're designing a harness or having a harness manufactured. On the board here we have lighting at the front, we have cooling fans, headlights, dip and main beam, and then I like to move backwards across a vehicle when you're thinking about what you've got to have on your vehicle. And this vehicle has a wiper motor, and we have a washer motor down here, but it is missing. We'll come back to this unit here. We've got a starter motor that you have to think about. We've got a brake switch and clutch switch, and there's a crash sensor here, and we like to incorporate that on our systems for safety. And we move all the way to the back of the vehicle where we have rear indicators, fog light, number plate light and reverse light. And moving slightly forward, if you're interested in this sort of equipment, there's an electric handbrake. But important things you'll need for your system are things like the fuel pump. The thing you have to consider is where things are located on your vehicle and what you want on your vehicle. The first thing you need to do is make a list of all the components. It's worth it because you will, and it's worth doing this over a few days. You will forget and remember certain components on your car, and you will soon build up quite a large list of stuff you've got to consider. That leads me on to this unit here that we bypassed a moment ago, and this is our version of a body control module, and that is a unit that replaces fuses, relays and all the electronics that give you functionality like indicators, heated screen timers, fuel pump controls and that sort of thing. This unit replaces a much larger set of hardware that you would see in a older style vehicle, and if you're building a kit car that is using an old system and you're having to strip all your wiring out and replace big fuse boxes or remotely located components, this greatly simplifies the wiring. And as I said, this is a vehicle. It is everything you need. So this could be taken off and it could run your car. So this gives you an absolute impression of what is needed and how neat you can, if you're inclined to go this way, create a system. On here, the unit here has the main power coming in. So we use a modern system where the battery and alternator supply the control module. We have switches coming in, or data if you're into the electronic panels and that sort of thing, and then out of it comes power, and inside there are your fuses and all the smartness to control everything in the right order for your IVA compliance, for your safety with your crash switch, for your smart functions. This unit can be upgraded to have RF switching, which is a modern thing where you have switches on your steering wheel, or the switches on your vehicle are not physically connected to it. It simplifies the wiring, but it also gives you some really smart ability to control things in different ways and make the most out of your electrical system. But the very first thing you need to think about is where you locate everything and how you draw up your harness. And we'll talk about the considerations of how you mount things, where you run your wiring so you're away from exhaust systems, away from moving parts, and also where you fit it to make it simple and easy, because you might never touch the wiring loom again. but you might want to change your engine, upgrade, improve functionality. So burying it underneath the floor pan that's riveted down is not the way forward. So we can talk about that. And then we will talk about the wire sizes and what you should do. When you've created your list of components, it's then useful to put next to each of those components the amount of electricity they use. I'm using that as a crude way of describing their current draw and their voltage, but that then tells you what size wire. And we use a very particular type of wire. It's modern automotive grade thin wall, and if you're used to your old Lucas systems, it looks woefully too thin. We can discuss the sizes and how you rate it, but by rating that at the right size, you can reduce the size of your wiring, which means you have a neater job, which is very important if you're looking to have a clean car. If you're into motorsports, the rating means weight, and if you're just building a car, why have really thick cables when you can have some nice thin ones that allows you to make it cheaper and simpler? Once you've started your little notes or your little spreadsheet, if you've got the ability to use Excel, that's brilliant because you can put columns and add information on it. Once you've thought about where your components are going and how you're mounting them and what wires you need and what current each item is drawing, the next thing to think about is your connections. So you might, in this layout here, we've run wires straight from the lights all the way to the control module with no connectors. But you might want to pass through a bulkhead. You might want to have a grommet there. You might want to have an interface connector. The connectors themselves are important. So on your spreadsheet, you want to write down what the connector is, and because you can move from this very generic connector here, which is junior power timer for a Ford, to the old-fashioned type of Lucas, all the way through to these bulkhead type connectors that are motorsport. So note down on your spreadsheet how many pins you've got, because we need to know, has it got a ground and a live? And you can, if you note the pin number down, you can note whether it's the feed to the light or consumer. And I'll use the word consumer on a number of occasions because that's the easiest way to describe a wiper motor, a starter motor, a fuel pump, a light, an LED, by calling it a consumer. It uses electricity and therefore it's a consumer. So knowing what the connections are to the consumer is very important in designing a wiring loom. We need to know whether it's a generic connector like these, whether it's a specific connector for a washer pump. We're able to use your old wiring loom and reuse connectors. The terminals are usually readily available, the connectors are not. So keeping a note of what you need is very important. And then you can start to work out your routing, and that will tell you whether you want one of these sorts of connectors that goes through a bulkhead. And if it's inside the vehicle, it can be one of these, which is not waterproof. And if it's outside the vehicle, we can supply waterproof connectors of varying different types. And to do that process of supplying you with a connector, or you reusing your own connectors if you're building the system yourself, you need to know how much power is going through it, because a connector has a rating, anything from 3 or 4 amps up to 30 or 40 amps. So knowing that you're connecting to a headlight bulb, which is 55 watts and 4.8 amps, that instantly tells you, or tells us, what sort of connector you need to use. When you've done that part, we've been discussing the outside, the consumer end of the system, you have to consider how you're triggering these things. So an indicator needs an indicator button, switch, stalk. your cooling fans, your wiper motor all need these switching. So the next thing you need to do is think about how you're controlling those circuits, what you want, whether you want conventional switches on the dashboard, whether you're buying a smart switch panel that's on CAN bus, or, as I mentioned earlier on, with this system we can expand to using RF, wireless communications, no connection between this unit and the fuse relay box. And it allows you to have a combination of all buttons on your steering wheel working all the systems, or all mechanical, all manual switches on the dashboard working all the systems, or a hybrid combination of them. I quite like this technology because it's really smart, particularly in a kit car where the dashboard might be too far away because you're sat quite far back, being able to reach your indicator buttons. But the system works very simply. You press a button and you get an indicator function. You press, if I select the right button, the wiper, that's on intermittent mode. The control unit we can program to do lots of different functions. You have access to it with a user interface, and it allows you to adjust timings for intermittent and number of pushes that do activate your functions. And this one you just keep pressing, that's speed 1, press again and it stops. So a wireless system is very useful for the kit cars and really simplifies your wiring. But it is important to consider what controls you want. And of course you have to have there's controls you will have to have. Brake light, for instance. So if I press the button there, we have a brake light trigger. We, as I keep mentioning, because I'm very concerned about safety, when we build any system, we are very mindful of not being able to start the vehicle in gear. If you bump into something, the fuel pump doesn't keep running, your electric system's turned off, and we have here the kill switch. That has to be considered where you mount it. So you have two parts to your system creation. One part is where your consumers are and how you mount them, and the other part is how your controls work. So everything from your steering wheel and your indicators and horn down to your fuel pump trigger and your engine management system. Having got to the controls and discussed switching and switches and how you interact with the system, we have talked about mounting, we've talked about cabling, we've talked about the consumers and the central controls for your vehicle. We will be doing further videos focusing in on very specific areas to consider, and hopefully you'll be able to use these further videos to narrow down and really understand how you want to create a system, how you should create a system, or if you're not interested in doing that, how you communicate that information to us so we can create you the best systems. And we'll be talking about location of components and how you best mount them, about the wiring and how that all works, about our control modules, and we'll do a lot of information on those because we'll compare those to fuse and relay boxes, and we'll discuss other general topics around sort of safety controls and fuel pumps and that sort of thing. Thank you for watching the video. My name's Jay Simkins. I'm Technical Director here, and if you have any questions at all, please don't hesitate to ring, email or contact us at a show. I'm always very happy to talk about the systems and talk you through what you need to know and what you need to do.